So I want to do a couple more examples for you guys of how to solve quadratics using completing the square. So we have the problem x squared plus 16x minus 12 equals 0, and we're going to solve this by completing the square. So the first thing I'm going to do is I'm going to rewrite this as x squared plus 16x plus blank, and then minus 12 equals 0 plus blank. And again, whatever I do to one side of the equation, I have to do to the other side. So 16, well, that is going to be 2 times 8. So that means that my other blank, my red blank, has to be 8 squared. Because remember that whatever number you get here is always the same number that you use here to square that. And 8 squared is going to be 16. I'm sorry, 8 squared is going to be 64. And if I add 64 on the left side, I have to add 64 on the right side as well. And now I have a new problem that says x squared plus 16x plus 64 minus 12 equals 0 plus 64. And remember that this x squared plus 16x plus 64 here is going to factor really nicely into x plus 8 squared. And then I still have this minus 12 that I'm going to bring down. And on the right side, I had 0 plus 64, which is 64. So I'm going to make this problem just a little bit simpler because I can. So we are going to take our x plus 8 squared minus 12, and we're going to solve this. Well, to solve it, I need to get x by itself. So the first thing I'm going to do is I'm going to add 12 to both sides. So then I get x plus 8 squared is equal to 76. And then I need to get my x plus 8 squared alone. So we're going to get that x alone. So I'm going to take the square root of both sides, because squaring and square rooting are going to cancel each other out. So I'm left with x plus 8 equals the square root of 76. And my square root of 76 can be simplified. So if you think about the number 76, 76 is 1 times 76. It is also 2 times 38. And lastly, it is 4 times 19. And if I look at these numbers and I look for perfect squares that show up here, well, 4 is a perfect square and 1 is a perfect square. Of those two numbers, 4 and 19 is the biggest. So that means that I can rewrite this x plus 8 equals 76 as instead x plus 8 equals the square root of 4 times the square root of 19. And the square root of 4 is really positive and negative 2. So now I have x plus 8 equals positive and negative 2 times the square root of 19. And then to get x completely by itself, I'm going to subtract 8 from both sides. Remember, we cannot combine this negative 8 with the 2 times the square root of 19. And the reason is because that 2 has, the 2 square root of 19, has that square root of 19 attached to it. And our negative 8 does not have a square root of 19 attached to it. So we just rewrite the problem as x equals negative 8 plus or minus 2 times the square root of 19. And that would be our final answer for this problem. Now, I know that it doesn't talk about this, but I want to talk about this for this problem. That really, this is two solutions. The first solution is x equals negative 8 plus 2 times the square root of 19. And our second solution is x equals negative 8 minus 2 times the square root of 19. So it's important to remember that that is really two solutions. One's plus and one's minus. And both these are going to be real solutions. And the reason they're real solutions is because there is no imaginary number in the problem. All right, our next problem is x squared plus 4x plus 13. So we're going to solve this by completing the square. So I'm first of all going to rewrite this. X squared plus 4x plus blank. We're going to set it up so that it's ready for completing the square. Plus 13 equals 0 plus blank. And if we think about the number 4 here, 4 is 2 times something. So this other blank is going to be something squared. Well, that works out well to be 2 times 2 gives me 4. So my other blank is going to be 2 squared, which is also 4. So if I add 4 to the left side, I have to add 4 to the right side. And then when we look at our problem now, hopefully you remember that our x squared plus 4x plus 4 is going to factor, and it factors into x plus 2 squared. Then I still have that plus 13 equals 0 plus 4 is going to give me 4. So I'm still trying to get this x by itself. That's always the goal here, is to get x alone. So if I'm trying to do that, the first thing I need to do is I need to get rid of that 13. To get rid of the plus 13, I'm going to minus 13 from both sides. And when I do 4 minus 13, I'm going to get negative 9 on the right side. So that means that x plus 2 squared equals negative 9. And then square root both sides, and I get x plus 2 equals, the square root of negative 9 is going to be a positive and negative 3i. Remember that the reason that there is an I there is because there was a negative under the square root. Negative under the square root is automatically going to produce an I in your answer. So then to get x completely alone and to finish solving my problem, we can subtract 2 from both sides, which is going to give me x equals negative 2 plus or minus 3i. And that would be your answer to your problem. And again, that is a problem that has 2 solutions. This time we know they're going to be 2 imaginary solutions or 2 non-real solutions because I had an I in my answer. Alright, so the next thing we're going to talk about is how we can determine the number of solutions without having to solve the problem. And we can use the discriminant to help us figure that out. And hopefully you remember that the discriminant is the equation b squared minus 4ac. And where I get a, b, and c from, where they come from, because I don't make those numbers up, is I get them from my standard form of my quadratic. So a quadratic should be in the form ax squared plus bx plus c, always. So whatever number is in front of a is going to go in this part of our formula in place of the a. And whatever number is in front of x is going to be the part that we end up squaring. And then whatever number is over here by itself on the end is going to be the c value in our discriminant. We have the problem x squared plus 6x plus 14. So the very first thing we're going to do is we are going to identify a, b, and c. So a in this problem is 1, b is 6, and c is 14. So if I plug those numbers into the discriminant, my b squared minus 4 times a times c, well, the b is going to be positive 6. So it'll be 6 squared minus 4 times a, which is 1, times c, which is 14. And 6 squared, I'm going to do my math now. So 6 squared is going to be 36. And then we have negative 4 times 1, which is negative 4, times 14 is going to be negative 56. So now I have 36 minus 56, and 36 minus 56 is going to give me an answer of negative 20. So hopefully you recall that if your discriminant is negative, which our discriminant is negative, because it is negative, that means that this particular equation has 2 non-real solutions. Okay, and the reason that we know that this discriminant has 2, or this formula has 2, this equation has 2 non-real solutions is simply because my discriminant was a negative number. So I'm going to write that down here. I'm writing a different color So I know that because I got a negative number. That's a negative sign. So because I got a negative number, that is how we know that the discriminant is going, or that there's going to be two non-real solutions. All right, our next problem says 4x squared minus 2x minus 5. And again, we're going to determine how many solutions there are. So we're going to find the discriminant A, B, and C. So A is the number in front of x squared, which is 4. B is the number in front of x, which is negative 2. C is the number by itself, which is negative 5. My discriminant formula is b squared minus 4ac. So I'm just going to plug in the numbers that I have. B is negative 2, so negative 2 squared. Minus 4 times a is 4 times c is negative 5. Negative 2 squared is positive 4. And then I have negative 4 times positive 4, which is negative 16, times a negative 5 is going to give me a positive 80. And 4 plus 80 is going to give me 84. So we look at this number, and this number is positive. So since it is positive, that means that there are two real solutions. And the reason that we know this number is two real solutions is because this 84 here is really a positive 84. So that's what makes it two real solutions. And our last problem, we have x squared minus 10x plus 25. So a in this case is 1, b is negative 10, and c is positive 25. So our equation is b squared minus 4ac. B is negative 10 in this problem. So again, make sure you're using parentheses around that negative 10. We talked about that today. If you take out a number and you put in a letter, you need to put it in parentheses. Make sure you're being purposeful about that. So negative 10 squared minus 4 times a, which is 1, times c, which is 25. And negative 10 squared is going to be positive 100. Then you have negative 4 times 1, which is negative 4, and that times 25 is going to be negative 100. Whenever you have 100 minus 100, that gives you 0. So that was the third possibility for our discriminant. And whenever our discriminant is 0, that means that we have one real solution. Means we have one real solution. Now I would go back and look at that chart that was in your book. I believe it was on page 206 that told you about the solutions, just to verify everything. Last thing, just as a reminder that your homework is due on Monday. And for homework, you had to do a total of 10 problems. You had to do problems 3 through 12 from section 4.3. So it starts somewhere, I think, on page 211, 212, 213, somewhere around there. All right, good luck.